We're going to pick it up with number 22 here. Find the length of an arc intercepted by a central angle theta in a circle of radius r. Round your answer to 1 decimal. Okay, you have to remember your formulas now. So S equals theta r, we call it SOAR, and I know that's a little bit, the book normally writes it a different way, but it helps us remember with SOAR. You must have radians. So I'm giving you one where it is radians. So your angle is 12 pi over 11, and I gave you a radius of 17.98. Guys, it's just a matter of let's multiply. So take everything in your numerators and multiply. 12 pi times 17.98, hit enter, and then divide by 11, and you should get it. 61.6. That should be it. There you go. A. Okay, now this one is a little bit of an upgrade. You are still using the SOAR formula. Problem is this is degrees. You have to catch that. You have to convert. Now I don't care if you convert first and then put it in your formula, or if you convert in the formula. The way I'm going to show you is we're just going to do it in the formula, so it takes up less time. So it's just got to click in your head, hey, that's degrees. So I need to take a little bit of time and add this little conversion factor. That will take care of the fact that, hey, I got degrees. So put your radius over here, and then you rock and roll just like we did a while ago. Keep in mind, these are all numerators, so you got your 10. We need the pi times the 16.46, and then we're going to come back and we're going to divide by 180. So I got 2.9 inches. Works like a charm. Okay, now this one's a little odd, but it's not hard. Just be careful because it seems like there's a vital part of information that is up here in the instructions. So you have to pick up the fact that the radius of the Earth is 6,400 kilometers out of that part. Otherwise, you're going to be floundering around. So it says find the distance in kilometers between these two cities, cities A and city B. If they're lined up, guys, you need to know the degrees apart. So if one of them is 16 degrees north, the other one is 24 degrees north. 24 minus 16 is 8. So basically, our angle is 8 degrees. You're subtracting these two angles, okay? So, and your radius that you're using is 6,400. And you're basically just using your little formula again. Same thing we did in the other problem. It's degrees, so you're required to convert while you're in your formula. But it's just a matter of typing it in. 8 pi times 6,400. And then come through and divide that out. And we've got 894 once you round it. I had 893.6, but they rounded it to the nearest kilometer, so B is going to be our answer. Okay, solve the problem. Electrical wire is being wound around a drum with radius of 0.5 meters, so that looks important. Radius is 0.5 meters. How much line would be wound around the drum if it's rotated through an angle, okay, of 288 degrees? It's the same thing. Because if we're talking about going around the drum, the around part is the arc. So they're asking you for arc. So here we go again. S equals theta r. And it's degrees, so once again, it's very redundant, guys. You're converting. It's a little weird because your radius is 0.5. So 0.5 meters. So our answer would just be in meters. But it's just a matter of typing all your information in. Let's see here, divide by 180. And I get 2.51, but it is meters. 2.51 meters. Okay? So this is the classic gear problem. So it takes a little bit more thought, a little bit longer, but it's not too bad. You do have two wheels. They're rotating in such a way that the rotation of the smaller wheel causes the larger wheel to turn or rotate. Okay, so the radius of the smaller wheel is 6.5. There we go, centimeters. And the radius of the larger wheel is 19.6 centimeters. Through how many degrees will the larger, and it did say degrees now, will the larger wheel rotate if the smaller one rotates at 223 degrees? Okay. Now the key to this is that the arc lengths will be equal, because you think about it, if these are gears, it never said that they were gears, but typically it's given in a gear format. If these are gears, the little teeth are going to match, and however far the small one turns, the large one's going to turn. So it's the arcs that are equivalent. So if you find the arc for the small one, and then use that in the next equation, you can get where you're going for the large equation, or the large gear. Okay, so let's start with the small guy. Okay, small. So I don't know my arc, that's what I'm looking for. I have degrees, so I have to convert, and my radius was 6.5. It's just a matter of typing. 223 pi times 6.5, and divide that by 180. I have 25 point, let's see here, they kept 2 decimals, so let me do that. That's going to be 30 whenever I round that. Okay, so if I go to the larger of the two, I have S equals theta R, but this is going to be 25.30. Now, in all honesty, I'm not clear in my calculator. So my lovely little decimals for this value where I rounded to write this down, it's still in my calculator. And I'm not planning on wiping it out. So when I get down here to work this problem, I'm going to have the true value. I'm not using 25.30 to do my computations. I'm using all those lovely little morsels. Okay, my radius is what I know, 19. And I'll tell you what, let's turn that around backwards, because that just feels just wrong. Let's do 19.6 and put theta right there. Okay, if I divide both sides by 19.6, see, that gives me that ability to keep all my decimals rolling in my calculator. So I'm just going to hit divided by 19.6, and I get 1.2907. Now that is radians, excuse me, because this formula gives radians. But the question asks how many degrees. So I need to convert. So I need to take this and do my 180 over pi. Again, I'm not clearing anything out of my calculator. So I'm just going to say times 180, enter, divided by pi, enter. And so when I do that, I got 73.95. See, it came out exact. I'm not off. I'm not, guessing. Am I right? Because I never once approximated. So just a heads up, keep the decimals, let them roll. Area of sector, you guys are responsible for that formula. I think you're only going to need it once, but you still need to know it. There you go, 1/2, theta r squared. So same rule as before, you have to have radians. So we got our 1/2, they told us 23.860 degrees, so obviously we need our little conversion factor in here. And our radius is 20.11. That has to be squared. So I'm going to come in here and I'm going to type 0.5. That takes care of this guy. Times 23.860 times pi. So I'm missing him, okay? And then I'm going to say times 20.11 squared. And I'm just squaring this part because that's all it's got squared. Once I get that value, I'm going to come back and say divided by 180. So I've got 84.21. And it is square feet because we are talking area here. Anytime you use area, you're going to have square units. Okay? Keep rolling. Exact circular function. So a little deja vu. We've already done a little bit of this. Negative 7 pi over 4. Let's see here. This would be 4 pi over 4. And we're going negative. So think of this as 0 and negative 8 pi over 4. But we're spinning this way. So we've got pi over 4 right there. You guys are supposed to be thinking about 45 degrees. 1, square root of 2. Sine is opposite over hypotenuse. We've got to fix him, square root of 2 over 2. I think we've done that problem already. Okay, cosecant of 5 pi over 3. My brain does not do cosecant. I'm going to do sine of that angle and turn him upside down. Okay, so let's see, where is 5 pi over 3? Well, this is 3 pi over 3. Remember, build off of your denominator. This is 6 pi over 3. 5 pi over 3 is closer to 6, isn't it? He missed it by pi over 3. Now, hopefully you're thinking, oh, pi over 3 is 60 degrees. Well, that would be a square root of 3, a 1, and a 2. Now, doctorate, your negative comes over here because he went down. So you need to do sine of that to get started. Sine is opposite over hypotenuse. But that's not what we asked for. What we asked for was cosecant. So take that and turn him upside down. Well, when we did that, we kind of made a mess. Now we've got to fix him. There we go. So it was option D. Cotangent of pi. Okay, a little different here. We don't need a triangle, we need the unit circle. So if you end up with 0, pi over 2, pi, or 3 pi over 2, or even 2 pi, draw your unit circle. Pi's over here. Make sure you put your ordered pairs in the right order. The Algebra 3 class just did this and had several kids do their ordered pairs backwards. It was sad. Okay, cotangent. With your quotient rules, you were supposed to tell me that cotangent was cosine over sine. And remember, cosine is the first one, sine is the second one. So the cosine value is -1. The sine value is 0. Ooh, we have a 0 in the bottom. That would be undefined. C. Okay. Use a table to calculate the function. Okay, now it does not say anything about it being circular, but guys, since this does not have degree on it, this is radians. Put your calculator in radians. You have to go to mode. Go down to the third line, hit enter. Make sure it's in radians. So you do not have a secant button though. You've got to work in reciprocals. So do cosine 0.2864. So we're typing 1 divided by cosine 0.2864. The zero is not necessary. So 1.042, and it actually does 46, but this will work just fine. Option A. Okay. Let's see what else we got. Tangent. You do have one of those. So tangent of 0.2068 works like a charm. It's 0.209799. Okay. Well, I don't think these went out that far, so we have to round. Is that right? Wait. What did I do? Yeah, here it is. My bad. Right here. Okay, so this 7 turns into an 8. It's C. Okay, so watch your rounding. Oh, goodness, I was looking at the back. Didn't even look at the front. Yeah, makes a big difference, doesn't it? So don't let your eyes start swimming. Okay, this says find the value of S in this interval. And I tell you what, we've got like 4 problems left, and these all kind of go together. So what we're going to do is we're going to stop right here, and we'll do the last ones in the last video.